Hello everyone, hope you all are doing well. In this video, we will discuss on LeetCode problem number 611, which is valid triangle number. So in this problem, we have given one nums array and we need to return the number of triplets from this nums array such that these triplets will make a triangle, and the triplets are nothing but the side length of a triangle, right? So, for example, in example 1, like in this example 1, we have this nums array like this, and then here the valid combinations are this. Now, how can we say that these are the valid combinations? So, you need to understand one triangle property. So, the triangle has a property that if A, comma B, comma C are the side lengths of a triangle, then sum of two sides must be greater than the third side, which means A plus B must be greater than C. Similarly, B plus C must be greater than A, and C plus A must be greater than B. If these triplets will satisfying this condition, then we can say that A, comma B, comma C is a valid combination, and we can form a triangle with this side lengths, right? So that this is the only condition that we need to apply in this nums array. So what we can do here, we can select the A from this nums array, right? So what are the possible combinations here? A can be any number from this nums array, right? So this n, right? Then B can also be like n minus 1, right? And similarly, then C can be n minus 2. So possible combination is equals to n to power 3, right? Now if you see the time constraint, the length constraint, num's length can be between 1 to maximum of 1000, right? Now if we will go with this brute force approach, where we will go through every possible combination and then we will check whether that combination is satisfying this condition or not, and based on that we will return the count. But it will take n to power 3 complexity, right? Which will be equivalent to 10 raised to power 9. And that approach will give you time limit error, right? So how can we improve the time complexity here? So if you see, one thing that I'm pretty much sure that that is coming to your mind is, can the sorting of this nums array, can we get any benefit of that if we sort this nums array, right? So in this example one, the nums array is already sorted, but if you see in example two, it is not sorted, right? Now if we sort it, can we reduce the possible iteration that we need to do? Yes. So how can we reduce that? Let's understand with maybe example number two we will take. So we have the nums array like this. Okay. Now after sorting, it will be like 2 comma 3 comma 4 comma 4, right? Now if I am taking A like the A as 2, B as 3, right? Then C can be either this value or this value, right? So C, there are three conditions, right? A plus B must be greater than C, B plus C must be greater than A, C plus A must be greater than B, right? Now if you see, right, this is sorted. So A will always be greater than here B, and B will always be, B will always be greater than A, and C will always be greater than B. If we choose the number like in this way only, right? First this 2 and then this B as this 3, the 3, 4 or something, and then C is also in the right side, right? So we can say that here After sorting, we can say that A is always less than B and B is always less than C. If we will fulfill this condition, if this condition is fulfilled, right? That means we are saying that this A plus B will be greater than C. Then can we say that B plus C will always be greater than A? Can we? Because we are saying that C will be always greater than A. So if we remove A with C here to get the second condition, the sum will always increase. It will not decrease, right? Because C is always greater than A. So A plus B, right? So C plus B will always be greater than A plus B, right? With this particular condition. I will say it like equation 1. So we can say that A plus B, C plus B will always be greater than A plus B. Why? Because we are just replacing A with C. Now since C is greater than A, so this sum will always be greater than this sum, right? So if A plus B is greater than C, then C plus B will always be greater than A. Because here we are reducing and here we are increasing, right? This in this condition, if you see, if you compare these two conditions, so here we will increase the sum if we remove A to C, right? And if we remove C to A, then we are decreasing this value. So this condition will always be satisfied, right? And similarly, this will also be always satisfied. Then we can say that if this first condition is satisfied, then other two will automatically get satisfied. I hope you get this, right? So if we are going from left to right, I choose this A. Then again I am going from this I plus 1 index and I choose any of this value as B. And then C. What will be the C value? So what I can do here is I can just check I will just iterate until and unless this condition is satisfied, right? In the third loop, I will keep on iterating until and unless this condition, I just need to find that particular index, right? Where this condition will get break and there I will stop, correct? So for example, if we choose A is equals to 2, B is equals to 3, then we will check for C that 2 plus 3 is greater than 4. Yes, so this condition is satisfied. So again then we will check for this. Again then 2 plus 3 is greater than 4. So this C can be either this particular value or this particular value, right? So here we can say that okay, I am getting two combinations. So here I get two combination. Now let's suppose A is 2 only and now B I am choosing as 4. Now does 2 plus 4 is greater than 4? Yes. So here also we can select C, right? Now let's suppose with A, now I'm done with this loop, right? B as 4. Now if can I choose B as like this? No. Then there will be no value for C, right? So thus I am done with this iteration. Now let's suppose I am choosing A as 3 and B as 4. Then this 3 plus 4, if I choose C as 4, then will this satisfy the condition? Yes. So this value is also I can choose, right? And I think we are done with all the combinations here. So what can be the values we can give here? Here from here two values, here one combination and here one combination. So in total four combinations, right? So that's how. Let's take another example. So if we have the nums array, the sorted nums array like this, like 4 comma 4 comma like this. Now if I choose A as 4 and B as 4, right? So does 4 plus 4 will be greater than 9? No. So we will stop the iteration here only. So with this combination of A as 4 and B as 4, I will not find any C value which will give me the proper triangle. Why? Because if we go to right, C value will keep on increasing, right? So it makes no sense to go further, right? If this particular value is greater than this 4 plus this sum of A plus B, then the right value will always be greater, right? So I will just stop iteration here. Okay, now I will check for A is equals to 4 and then B is equals to 9. So now if you see that A 4 plus 9 is greater than 10, yes. So this is valid combination. Now this is completed. Now let's suppose A is equals to 4 and B is equals to 9. So again, does this 4 plus 9 is greater than 10? Yes. So this is also a valid combination, right? Now if you see A is equals to, now if I'm going to the second index, right? 4, this one was at I is equals to 0. This is at I is equals to 1. And then similarly here B will be 9. And then this 4 plus 9 will always satisfy this condition. Will also satisfy this condition, right? So similarly here we have how many? Three combinations which is valid. So that's how we need to solve it. So we will keep doing this combination. We will keep iterating A and B, but then for C value we can stop as an then we will get the if this condition is not fulfilled, right? So let's try to solve this problem in term with code. So we will have n is equals to nums dot size. We will sort this nums array first. Okay. Now what we will do, we will first have this our result value which will store the count, and then we will first iterate for all possible a values. So we can iterate a from I is equals to 0 to I less than n minus 2, I plus plus. Then b will be from int I j is equals to I plus 1, j is less than n minus 1, and then j plus plus, right? Now we need to think the value of k, right? So what we can do here, we will just from with j only I will initialize the k as well. K will be I plus 2. Okay, and then what we can do here is we can have one for loop which will say that while k is less than n, we will keep checking, keep increasing this third C index until that condition is not satisfied. So where k is less than n and nums of I plus nums of j is greater than nums of k. So we are keep iterating until this a plus b is greater than c. Here I index pointing to a, j index pointing to b, and c index is pointing to k, right? So here we are just keep iterating. What we will do? K plus plus, right? Simple. Now we will just increase the count with how many possible combinations we can have. So I and j, right? And from j plus 1 till k, I can choose any value of c, right? So the possible combination that I can have is k minus, not till this k will be the value where the k will point to the index now where this condition is not fulfilled, right? So I can populate from, I can take c value from j to k minus 1 index, right? So this result value will be like k minus j minus 1. I will just add a comment here that c can be in between j to k minus j plus 1 to k minus 1 index, right? So that's where how many possible combinations we can have for c is k minus j minus 1. And this way we will be able to calculate all the particular combinations. Now let's just run the test case. Okay, our test cases are accepted. Let's try to submit this. um, our out oh okay, so it should be like this: maximum of k minus 1 comma j comma 0. Let's run this. Okay, now let's try to submit this. Okay, this is how we solve this problem. Now let's understand the time complexity here. So the sorting will take O of log n, right? Here we are having an iteration. Here also we are having an iteration. Now this particular is constant, right? Because we will just iterate until k is less than n, right? We will not going to iterate from 1 to n each for each j value, right? So we can say that this as constant, right? So this particular for loop will take n square, right? So the total time complexity here will be O of n log n, sorry, plus n square, which is equivalent to O of n square. And what about the space complexity? What will be the space complexity here? If you understand the sorting, so the sorting that we are doing here is via merge sort, right? And merge sort will always take O of n log n extra space complexity. Since this is a C++ function, we are not able to understand the extra complexity that this particular function will take, but it will use a merge sort algorithm. So hence that merge sort algorithm will use log of n complexity. So right. So that's how we that's how we have calculated the time and space complexity. I hope you understand how we solve this problem. Please do code by yourself. And if you like my video, please do share, like, share, and subscribe. Thank you, and see you in the next video.